making stuff, it's got to be good. We make a lot of stuff, cars, phones, even buildings. It's important that this stuff is made well. We want things to work properly. We also want them to be safe. This means making sure they are put together correctly. Precision is key in manufacturing. Every piece has to fit just right. Quality is also essential. We want things to last a long time. Safety is the most important thing of all. No one wants a product that could be dangerous. Manufacturing relies on careful processes. These processes ensure everything meets high standards. When we make things with care, everyone benefits. Imagine being able to look inside an object. You could see if there were any cracks or weaknesses. That's what non-destructive evaluation, or NDE, lets us do. It's like having superpowers. NDE is a way of inspecting stuff without taking it apart. We use different techniques to find hidden flaws. These flaws might not be visible to the naked eye, but they could cause problems later on. NDE helps us find problems early on. This way we can fix them before they become big issues. It's an important part of keeping people safe, and it helps make sure products are top quality. There are many different NDE methods. Each one uses a different principle to look inside materials. These methods are crucial in ensuring the integrity and safety of various structures and components without causing any damage. Let's learn about a few of them. Understanding these techniques can help us appreciate the science behind maintaining the quality and safety of the things we use every day. Ultrasonic testing, or UT, uses sound waves. This method is widely used in industries like aerospace, automotive, and construction. Think of a bat using echolocation. Just as bats navigate and hunt using sound waves, we use similar principles to inspect materials. We send sound waves into an object and listen for echoes. The time it takes for the echoes to return helps us determine the internal structure of the material. These echoes tell us if there are any cracks or voids inside. By analyzing the echoes, we can identify the size, location, and nature of any defects. Radiographic testing, or RT, is like taking an X-ray of your body. This method is particularly useful for inspecting welds, castings, and complex assemblies, but instead of bones, we're looking for flaws in materials. Radiographic testing can reveal internal defects that are not visible to the naked eye. X-rays pass through the object and create an image on film or a digital detector. The resulting image shows variations in material density, highlighting any internal flaws. Magnetic particle inspection, or MPI, uses magnets and iron particles. This method is effective for detecting surface and near-surface defects in ferromagnetic materials. We magnetize an object and apply iron particles. The magnetic field causes the particles to gather at any discontinuities, making them visible. The particles are drawn to cracks or flaws in the magnetic field, making them visible. This method is quick and can be used on-site, making it very practical for field inspections. Eddy current testing, or ET, uses electromagnetic fields. This method is particularly useful for inspecting conductive materials like metals. We induce eddy currents in a conductive material. These currents flow in circular paths and are affected by the material's properties. Flaws in the material will disrupt these currents. By measuring these disruptions, we can identify and locate defects. We can detect these disruptions to identify problems. Eddy current testing is highly sensitive and can detect very small defects. A visual inspection, or VT, is the simplest method. Despite its simplicity, it is often the first step in the inspection process. We use our eyes to look for defects on the surface of an object. This method can be enhanced with tools like magnifying glasses or borescopes. It may seem basic, but it's still an important part of NDE. Visual inspection helps identify obvious defects and can guide further, more detailed inspections using other NDE methods. Quality control is all about making sure things are made right. NDE plays a big role in this. It's like a detective sniffing out problems. NDE helps manufacturers meet quality standards. It ensures that products are free from defects. This leads to better products that last longer. And it helps prevent accidents and failures. By finding problems early, NDE saves time and money. It's much cheaper to fix a flaw early on. If we wait until later, it could mean scrapping an entire product. That's wasteful and expensive. NDE is essential for building trust with customers. When people know that products have been thoroughly inspected, they feel more confident in their purchases. Technology is always evolving, and NDE is no exception. Non-destructive evaluation, or NDE, is a critical process in many industries, ensuring the safety and integrity of materials and structures without causing any damage. As technology advances, so does the sophistication of NDE techniques. We're seeing some really cool advancements that are making NDE even better. Engineers are constantly pushing the boundaries, developing new tools and methods that enhance the precision and efficiency of inspections. Robots are being used more and more in NDE. These automated systems can perform tasks that are too dangerous or monotonous for humans, ensuring consistent and reliable results. They can perform inspections in hazardous environments such as areas with high radiation, extreme temperatures, or toxic chemicals, where human presence would be risky, and they can work tirelessly for long periods, improving efficiency. This continuous operation means that inspections can be carried out around the clock, reducing downtime and increasing productivity. AI is helping us analyze NDE data more effectively. With the power of artificial intelligence, we can process vast amounts of data quickly and accurately, identifying issues that might be missed by the human eye. It can recognize patterns and identify defects. Machine learning algorithms are trained to detect even the smallest anomalies, ensuring that no flaw goes unnoticed. This allows for faster and more accurate inspections. The integration of AI into NDE processes not only speeds up the inspection, but also enhances the accuracy, leading to better quality control. We're now able to create three-dimensional images of objects using NDE techniques. This advanced imaging technology provides a detailed view of the internal structure of materials. This gives us a more complete picture of what's going on inside. By visualizing the internal components in 3D, we can better understand the condition and integrity of the material. It helps us find even the smallest flaws. High-resolution imaging ensures that even the tiniest defects are detected, which is crucial for maintaining safety and quality standards. These advancements are making NDE faster, more accurate, and more reliable. The continuous improvement in technology means that inspections are becoming more efficient and dependable, and they're opening up new possibilities for the future of inspection. As we look ahead, the potential for further innovation in NDE is immense, promising even more sophisticated and effective inspection techniques. Section 6, NDE in action, from planes to phones. Non-destructive evaluation, or NDE, is a critical process used in a wide range of industries. It involves inspecting materials and components without causing any damage, ensuring they meet safety and quality standards. Let's take a look at some examples of how NDE is applied across various sectors. In the aerospace industry, NDE is crucial for ensuring the safety and reliability of aircraft. Technicians use advanced NDE techniques to inspect critical components. It's used to inspect everything from engines to wings, landing gear, and fuselage. These inspections help detect any potential issues before they become serious problems. By identifying and addressing these issues early, NDE helps prevent accidents and ensures that passengers can travel safely and confidently. In the automotive industry, NDE is used to inspect car parts for defects and inconsistencies. This includes everything from engine components to the structural integrity of the vehicle's frame. These inspections are vital for ensuring the reliability and safety of vehicles on the road. Crash tests and other safety evaluations rely on NDE to verify that cars can protect occupants in the event of an accident. In the electronics industry, NDE is used to inspect electronic components for tiny flaws that could affect performance. This includes examining circuit boards, microchips, and other critical parts. By ensuring the quality and performance of these components, NDE helps maintain the reliability of our phones, computers, and other electronic devices that we rely on every day. In the construction industry, NDE is used to inspect bridges, buildings, and other structures. Engineers use NDE techniques to assess the integrity of materials and ensure that structures are safe and sound. These inspections help prevent structural failures and ensure the long-term safety and durability of our infrastructure. From skyscrapers to bridges, NDE plays a key role in construction safety. These are just a few examples of how NDE is used in different industries. The applications are vast and varied, but the goal is always the same: to ensure safety, quality, and reliability. NDE plays a vital role in keeping us safe and making our lives better. Whether it's in the air, on the road, in our devices, or in the buildings we live and work in, NDE is an essential part of modern life. Section 7. The future of finding flaws. The future of NDE is full of exciting possibilities. New technologies are emerging that will revolutionize the way we inspect things. Three-dimensional scanning allows us to create highly detailed three-dimensional models of objects. We can then use these models to identify even the smallest defects. Augmented reality, or AR, overlays digital information onto the real world. Imagine wearing AR glasses that highlight defects in real time during an inspection. These advancements will make NDE even more powerful. We'll be able to find flaws more easily and accurately than ever before. Section 8. Why this matters to you and me. NDE might seem like something that only engineers need to worry about, but it actually affects all of us. NDE helps make the products we use every day safer and more reliable. It keeps our cars on the road, our planes in the air, and our buildings standing strong. Next time you get in a car, board a plane, or walk into a building, remember the important role NDE played in keeping you safe. Section 9. Keep on learning. This is just a glimpse into the world of NDE. There's so much more to learn. I encourage you to explore further and discover the amazing ways NDE is shaping our world. Stay curious, and remember, science rules. Please subscribe to our channel for more insightful content on manufacturing and technology. Stay tuned.